Hello everyone. In this video I'd like to introduce a new topic, set theory. We'll begin with some historical background and the context for why we study sets. Then we'll talk about what sets are and how we mathematically describe them. I'd encourage you to have your Math in Our World textbook on hand and pause this video to try the examples on your own as needed. I also wanted to point out that the textbook offers a try this one problem after each example in case you need even more examples than those in this video. We'll begin with section 2.1 from Math in Our World. Who developed set theory? Unlike other subjects in math, we can trace the development of set theory back to primarily one person, Georg Cantor. He was a mathematician who tried to answer some questions about infinity, and one of the things that he's known for is actually proving that there are more real numbers than rational numbers. Rational numbers are fractions, and even though we have an infinite number of both of those types of numbers, he showed that there's actually an infinity that's bigger than another infinity. You can imagine that this work was groundbreaking at the time. It was not well received, and tragically the criticism by his peers eventually led to nervous breakdowns, and he ended his life in a mental institution. Thankfully, we now widely accept his work, and it's too late for him to get the recognition that he deserves, but we can attribute all of our progress in set theory back to Cantor. If you're interested, here are a couple books on the topic. The one on the left is a biography of Georg Cantor, and it also contains quite a bit of information about infinity, questions dealing with infinity, definitely the philosophical theories behind his work, and just different questions about infinite sets as well. The book on the right is more of a general math kind of a book, very readable also, and this one has short answers, more like a paragraph, for just some questions that you might have on really any math topic. I've pulled a few excerpts from this one to give you an idea of the background for why we study sets. Set theory is one of the foundations of mathematics, so what it does is it allows us to have a way of organizing or talking about math, and then we can use that to go on and study other types of math. It's also a philosophical topic and is of interest to philosophers. And as you can see here, this excerpt says that the foundations of math provide ways for philosophers and mathematicians to try out general philosophical doctrines in a specific scientific context. So if you ever thought that math was black and white and that we agreed on all of the fundamental facts and things, well, that's not entirely the case, and there are some different approaches based on someone's philosophy. Well, what is set theory? Set theory is kind of redundant here, the mathematical theory of sets, but basically one goal or one aim of set theory fits in with the aims of logic research to find a single formula theory that will unify and become the basis for all of mathematics. So just as with many other scientific theories, even something like string theory, people are constantly searching for a way to unify and to find a way to describe the universe, and that's one of the aims for set theory as well. Okay, so let's start in on section 2.1, and this is the beginning of the information from Math in Our World. Some basic definitions. A set is just a collection of objects. A set is well defined if for any given object we can objectively decide whether it is in the set or not in the set. So for example, the set of letters in the English alphabet. That is a well-defined set because there are 26 letters, and if we're given a letter we can know whether or not it is in the set for sure, one way or the other. The set of great musicians. This is a set, but we wouldn't really consider it to be a mathematical set, and it's definitely not well defined. This one is subjective. You'll have many different opinions on who should or should not be in that set. An object in the set is called either an element or a member of the set. So G is an element of the set of letters in the English alphabet, but the Greek letter beta is not a member of the set of letters in the English alphabet. Okay, so element, member, words for things in the set. There are 3 ways to describe sets. Okay, we can list out the elements in the set, we can give a verbal description, or we could use a more technical set builder notation, and you'll see this one in formal math writing more often. It uses more symbols, and it's a shorter way to write very long descriptions. Another way to name a set is to use a capital letter, so you'll see things labeled like set A or set M. The roster method or the listing method, those are just 2 words for the same method. You list the elements between braces, those are the curly kind of these things, right, with commas between the elements. Elements can be listed in any order, and repeat elements are only listed once. So for example, we have set B here, okay, and I can tell that that's the name of the set because it's a capital letter, and we write set B equals, and then in curly braces you just kind of give a roster or a list of all of the things in that set, T, X, W, 1, and 5. So there are 5 elements in that set, and then notice that we can list those in different orders, but it still represents the exact same set. Right, so it's not like, for example, an ordered pair in algebra when you're graphing, like the point 2, 3. That's a different point than the point 3, 2. Okay, but in sets, doesn't matter. It doesn't have to be numbers, right? So for example, set S here. Set S is the set of that square symbol, a heart symbol, and a star symbol. Right? Repeat elements are only listed once. So if we had, maybe this is the set of objects on the page of a coloring book, and maybe there were 2 stars. Well, when we go to write the set, you only write the star once. Alright, let's practice. And pause if you want to, try these out on your own, and then if you want, you can use this video as a way to check and see if your answers are correct. You could also just read along in the textbook. Write the set of months of the year that begin with the letter M. Okay, so let's do this using the roster or listing method. So you do curly braces, and then you just list out the things in this set. So months of the year that begin with the letter M. Well, we have March, and we have May. All right, so you put a comma between those 2. All right, and then a closing brace at the end. Write the set of letters in the name Jennifer. All right, braces. All right, and capital versus lowercase doesn't really matter. It's still a J. There may be situations where you would be picky about that, but I'll take either one. Okay, so we have a J, we have an E, we have N. Now there are 2 N's, but we don't write it twice. You just write it once. Okay, I, F, a second E, we already have an E, and R. And that's it. 2 specific sets, or I'm sorry, 3, that your textbook will start to just assume that you know. The set of counting numbers or natural numbers. 2 words for the same set. These are the, kind of naturally, these are the numbers that you would probably learn first if you're a little kid and learning to count. So you usually start with 1, 1, 2, 3, 4, 5, 6, 7, 8, etc. And all of those numbers are the set of natural numbers, and we use this little scripted N to represent the natural numbers. So it's an N, but it has like an extra little bar to it. Get it one of these times. Okay. And then the sets E and O, other textbooks may not use these letters for these sets, but in this textbook, when you see an E, a capital E, that stands for the set of even natural numbers, 2, 4, 6, 8, 10, 12, 14, etc. And then O stands for the odd ones, 1, 3, 5, 7, 9, etc. Okay. Notice that 0 is not in this set. So often when kids are taught to count, they don't start with 0, and natural numbers don't either. All right, let's practice. Use the roster method to write the set of natural numbers less than 6. Okay, so less than means not actually including. So less than 6, we would start with 5 and then kind of go down from there. And we need to know where to end at the other end. Well, the first natural number, the smallest one, is a 1. So natural numbers less than 6 would be 1, 2, 3, 4, and 5. Okay, the set of odd natural numbers greater than 4. Okay, well, the first odd one greater than 4 is 5. 5, 7, 9, 11. And then we use an ellipsis just to indicate that this keeps on going. Okay, and then close the brace at the end. The set of natural numbers between 6 and 13. Okay, so between does not mean including. So if you put a 6 and a 13 in this set, that's incorrect. Between 6 and 13 would be 7, 8, 9, 10, 11, and 12. And the set of even natural numbers from 80 to 90. Now this one does mean starting at 80 and ending at 90. Okay, so from, include those two end ones. All right, so starting at 80, and then we need even ones all the way up to 90. 88 and 90. Two new symbols. The symbol, this little kind of a curved E here, means an element. Right, so that's used to show that an object is a member or an element of a set. Right, so if you're drawing this, I'll write it a little bigger. It's very curved with a line in the middle. Okay, example, let A be the set of days of the week. Then Monday is an element of set A. Okay, so the thing on the left is the element, thing on the right is the set. The symbol, kind of that E with a slash through it, is used to show that an object is not an element of a set. Okay, so you write your E symbol, slash through it means not an element. So March is not an element of set A because set A was the set of days of the week. All right, true or false statements. Oregon is an element of set A, where A is the set of states west of the Mississippi River. Okay, true. Okay, part B. All right, well, 27 isn't shown there in that list, but there's an ellipsis which indicates that the set continues, so we need to check a few more terms and see if eventually 27 would be in there. All right, so we need to find a pattern first, and it looks like these numbers, we have a pattern of adding 4 to get from each one to the next one. So after 17 would be 21, and then 25, and then 29, and it would keep going. But we can see from that we've skipped right over 27, so 27 is not in that set. Okay, Z is not an element of the set containing V, W, X, Y, and Z. That's false. Z is in the set. Okay, part D, zebra is an element of the set containing Z-E-B-R-A. Okay, kind of a trick here, but zebra, if we're looking at this as an element, that means the whole word as, as an entire word, right? And we don't actually see the whole word in the set, we just see single letters making up zebra, so this is also false. 3 is not an element of 12, 13, 14, 15. Right? That is true. So even though you see a 3 in 13, 3 is not an element of the set. There are 4 elements. They are the numbers 12, 13, 14, and 15. Okay, so we're in the middle of talking about 3 ways to describe sets. We've talked about the listing method. A second one is the descriptive method. And this one uses a short statement to describe the set. The description should be clear enough that someone can reconstruct the exact same set from the description alone. So if there's a possibility that your description leads somebody to write a different set than the one you intended, then it's not a correct verbal description. Okay, which of the descriptions below accurately describe the set containing 2, 3, and 4? All right, so kind of take a minute to look through these and see if any of those seem like they would be good enough. Okay, the first one, the set of numbers between 1 and 5. All right, well, our numbers are between 1 and 5, but this description could also maybe lead somebody to write, how about 2, 3.5, 4.3. Well, that's also a set of numbers between 1 and 5. All right, so we have to have something in our description that indicates what type of number it is, because just the set of numbers between 1 and 5 would include all of the decimals and fractions and irrational numbers like the square root of 2 and things like that. Part B, the pattern is counting up by ones. Okay, well, it's a true statement, but it doesn't describe this set because, first of all, it's not kind of like a noun phrase, the set of something. It's just describing the pattern, not the set. And then second of all, it also doesn't tell us where to start and end, right? The pattern is counting up by ones. Well, if I write this set, 10, 11, 12, 13, that pattern's also counting up by ones, right? So that one's not accurate enough. The pattern is counting up by ones from 2 to 4. That is a true statement, but we wouldn't say that this is the descriptive method because it's not saying this is the set of something. It's describing the pattern, not the set. All right, how about the set of natural numbers from 2 to 4? Okay, natural numbers indicates what type of number it is. That makes sure that we wouldn't write things like 3.5. And it tells us where to start and to end. So I think that one is accurate. Right, there's only one set of natural numbers from 2 to 4, and that's the set we were given. How about the set of integers between 1 and 5? Do you remember what an integer is? All right, well, integers are the natural numbers. Oops. All right, also 0. And then all of the negative natural numbers. -3, -4, -5, etc. Okay, so then the integers between 1 and 5, if you kind of look along this list, find the ones between 1 and 5, and that is our set as well. So that is another correct way to describe this set. So in other words, there is more than one way to correctly describe the set, but there are also descriptions that are not sufficient to describe only that set. All right, how about the set containing red, yellow, and blue? Is it the set of primary colors, a set of colors, the set of colors in the flag of Romania, or multiple options from those? All right, well, definitely part A, the set of primary colors. All right, those are, as long as you accept kind of that traditional definition of what a primary color is, then that's red, yellow, and blue. All right, a set of colors, not complete enough. We don't know which colors. We could write other sets that are not red, yellow, blue. The set of colors in the flag of Romania. All right, well, if you know this one or if you've looked it up, the colors of the flag of Romania are red, yellow, and blue. So that is a good description. All right, try it out. Use the descriptive method to describe the set B containing 2, 4, 6, 8, 10, and 12. Okay, so I would want to start by saying B is the set of all right, and then we look at what type of number this is. Well, those are natural numbers, and they also happen to all be even. Okay, so let's use that type of number to describe this. B is the set of even natural numbers, and not all of them, just a portion of them, so we have to say where this starts and ends. So you could say this a couple different ways. You could say from 2 to 12. You could say between 1 and 13. Or you could even say between other numbers, like between, how about 0 and 14? Because the only even ones between 0 and 14 would be those 2 through 12 set. Okay, how about the set -2, -1, 0, 1, 2, 3, 4, 5, 6. All right, well, these are not just natural numbers because we have these negatives and 0, but you can use that term we just talked about, an integer. So this is the set of integers. Okay, and we'll try it out from where to where or between where and where. Well, if you do from, it's got to be from -2 to 6. Or you could say the set of integers between -3 and 7. All right, a third method to describe sets. We've done listing, a verbal description, and then a more technical notation called set builder notation. This one uses variables to represent different elements of a set. It uses braces and then a vertical bar that's read as such that. Okay, so here's the set containing 1, 2, 3, 4, 5, and 6. And this equals, or is the same as, here it is in set builder notation. All right, so if we walk through and read this first x, you always read this as the set of all x such that the set of all x, and you can think of x just as like a general variable or a general element in the set. So it's like saying the set of all elements, and the vertical bar means such that, and then after the vertical bar we write the properties that describe the elements in the set. Okay, so the first part here, let me erase this line. Okay, this part, all right, there's your new symbol for element, and if you recall, the n, the fancy n there, means natural numbers. So we're saying that x has to be a natural number. So this is the set of all x such that x is a natural number and okay, then the second part, all right, you might want to review inequality symbols if you don't remember those, but that means x is less than 7. So we can say the set of all x such that x is a natural number less than 7. All right, and you might be thinking, why in the world would we use this? What's wrong with just listing 1, 2, 3, 4, 5, and 6? Well, there's nothing wrong with it when it's that simple, but sometimes you end up with a set that's very complicated and you need a shorthand way to describe it. And there are situations where the set builder notation is a lot shorter and faster to read. Okay, we won't do a whole lot with this notation, but it is used in your textbook examples, so I just want to make sure that you can read those sets and write some of the basic ones so that you can understand the examples. Alright, so let's try it out. Let's write these sets in set builder notation and then read how you would read the sets out loud. Okay, the set R contains the elements 2, 4, and 6. So we want to write R equals, and then we do use braces for the set builder notation, and then you always start with that variable x and the vertical bar. All right, so it's the set of all elements x such that, and then we need to describe what elements we have. So we need to come up with a symbolic way to describe 2, 4, and 6. All right, so think about what type of numbers those are. They are even. They're not decimals, they're not fractions. All right, well, notice that they are all from that set E, the even natural numbers. So we can say this is the set of all x such that x is an element of E, the even natural numbers. All right, so that narrows it down to 2, 4, 6, 8, 10, 12, etc. But then we need to have a way to describe that we only want the first 3, 2, 4, and 6. All right, well, one way you could say it would be we have to make sure that x is less than You could do 7, you could do 8. All right, so we want even natural numbers less than 7. Okay, and then we would read that out loud. The set of all x such that x is an element of the even numbers and x is less than 7. All right, the set W contains the elements red, yellow, and blue. All right, so this is the set of all x such that, right, and here we don't really have a mathematical way to describe those, so we can kind of do a hybrid here and throw in a verbal description. So we just want to say that x is, right, and rather than just listing the colors, we usually try to describe it in some way. So we could use the one we already talked about, x is a primary color. Okay, and the last one, the set K contains the elements 10, 12, 14, 16, 18. So K equals the set of all x such that x is, all right, similar to the first example here, x is an even natural number, and, all right, now we can't just say less than, we have to kind of cut this set off on both ends. We want to skip 2, 4, 6, 8, and we want to skip anything from 20, 22 on up. All right, so we could say x is between two numbers, and let's say it that way. X is between, let's do 8 and 20. You could also do 9 and 19, or you could do 8 and 19, or 9 and 20. Any of those would work. All right. So for that first part, the x is the element of, right? Recall you might want to use those symbols for natural numbers, even natural numbers, and odd natural numbers. And I'll throw this one in here as well. There is a symbol for integers. It's a fancy Z, and Z stands for Zahlen. That's the German word for, I think it's, I want to say it's for number. I'll have to check on that one, but that's from a German word. Okay, let's do one example, trying all three of these. All right, designate the set S with elements 32, 33, 34, 35, etc., using these three different methods. All right, the roster method. Okay, so we've been given the name of the set, so we want to make sure we use that. So S equals, for this one, it's the roster or listing method, so we use braces. And then you just start listing these out. And it looks like I need a little more space. All right, and the set continues, so you use the ellipsis, and then just end it in a bracket. Okay, the descriptive method. So we can say, let's say it this way. S is the set of all right, well, what do we have? What seems to be the property of these numbers? All right, well, you only have a few sets to really talk about right now. You've got natural numbers, even ones, and odd ones, and maybe integers. All right, so these are all natural numbers, so let's go with that. S is the set of natural numbers. All right, well, it continues on forever at the end there, so we really just need to say where the set starts. All right, so we want to say, you could say starting at 32, but it would be a little bit better to say maybe greater than 31. All right, it's better math vocabulary to say it that way. S is the set of natural numbers greater than 31. All right, you could also say greater than or equal to 32, but you probably wouldn't want to say from 32 because then you have to say, from where to where, and it's not really technically correct to say from 32 to infinity, so stay away from that one. Okay, and finally, set builder notation. S is the set of all, always starts the same, the set of all x, such that x is, well, we already know it's a natural number, and we said that it's greater than 31. X is greater than 31. All right, writing a set using an ellipsis. So sometimes we can also use an ellipsis in the middle of a set just to shorten the amount of writing we have to do. So write the set containing all even natural numbers between 99 and 201. Well, there are quite a few of those, and you probably don't want to write all of those out. So we start with the first one. The first even natural number between those is 100. And then you write just a couple until you kind of establish a pattern for what types of numbers are in this set. Usually 3 or 4 is good. And actually, let's even skip that one. 3 is good enough. All right, so somebody looking at this can see that we mean the even natural numbers. And then you write the ellipsis to indicate that it continues on in this same pattern for a while. And then you just put the spot where you stop. All right, so the last one of those numbers is 200. And then you don't have to write all of those out. All right, using the roster method, write the set of all letters of the English alphabet. All right, same thing. Just write a few until somebody gets the idea of what you mean. Okay, another comma. And then the last one. All right, and that's it. Okay, we'll stop there, and we'll pick up in the next video with some more basic concepts from set theory. But in this video, we've talked about what a set is, and then 3 ways to mathematically describe sets.